Welcome back to session 18 of GED Advanced Graphs and Functions. Some patterns do not grow by adding the same amount, they grow by multiplying by the same factor. That is exponential change, and it powers things like populations, interest, and radioactive decay. Today we learn to recognize it and model it. Let's begin slowly. Here's the core difference. A linear pattern adds the same amount each step. 2, 4, 6, 8. Always plus 2. An exponential pattern multiplies by the same factor each step. 2, 4, 8, 16. Always times 2. If you are repeatedly multiplying instead of adding, the pattern is exponential. The multiplier is called the factor, written b. If b is greater than 1, each step makes the quantity larger. That's growth. If b is between 0 and 1, like 1/2, each step makes it smaller. That's decay. So a factor of 2 doubles, and a factor of 1/2 halves. The size of b tells the story. An exponential model has a clean form. Y equals a times b to the x. The a is the starting value, the amount when x is 0. The b is the factor you multiply by each step, and the x, up in the exponent, counts how many steps have passed. Those three pieces describe any exponential situation. Let's build a model. A population starts at 100 and doubles every hour. Step 1. Find the starting value. At hour 0, there are 100, so a equals 100. Step 2. Find the factor. Doubling means multiplying by 2 each hour, so b equals 2. We now have both pieces. Step 3. Put the pieces into the form. Y equals a times b to the x becomes p equals 100 times 2 to the t, where t is hours. Now we can use it. After 3 hours, p equals 100 times 2 cubed. 2 cubed is 8, so p equals 100 times 8, which is 800. The population reaches 800. One careful reminder: always evaluate the exponent before you multiply. In 100 times 2 cubed, you must compute 2 cubed first, that is 8, and only then multiply by 100. Computing left to right and doing 100 times 2 first would be wrong. Exponent first, then multiply. 3 traps. First, do not treat doubling as adding 2. Doubling multiplies. Second, for decay, use the fraction that remains, not the percent lost. Losing 30% means keeping 70%, a factor of 0.7. Third, remember any factor to the 0 power is 1, so the model gives the starting value at x equals 0. Let's lock it in. Exponential change multiplies by a fixed factor each step. The model is y equals a times b to the x, where a is the start and b is the factor. A factor above 1 grows, a factor between 0 and 1 decays. And always evaluate the exponent before multiplying. Exponentials. Understood. Wonderful work today. You can now recognize exponential change, find growth and decay factors, and write a model. Your mastery check is the 10 practice questions for this session. For each one, find the starting value, find the factor, then write y equals a times b to the x. To read the full lesson notes and practice more GED graphs and functions questions, visit the course page at www.bridgetoexam.com. I will see you in session 19, where we shift, stretch, and reflect graphs with transformations. Keep going. You are doing great.